Assalamualaikum warahmatullahi wabarakatuh. Good morning to everyone. And we meet again in the we call lecture 2 of 3 for this topic, still the topic of probability. Okay, so we find the recall probabilities of intersection and union of two events. Okay, probability of two events A or B occurring are calculated using additional probability rules such as this one here. Okay, union means that we're taking them all. Okay, so in a class of 30 students, 5 out of 20 girls and 7 out of 10 boys are members of the mathematics society. A student is selected randomly, so what is the probability that the student is a girl or a member of mathematics society? Okay, now let's take out all the informations. Okay, so 20 girls and 10 boys. 20 girls and 10 boys. So 20 plus what? 20 plus 10 equal to 30, and 5 of the girls is a members of mathematics society, and 7 out of boys here is a members of mathematics society. So now the question is, a student is selected randomly. What's the probability that the student is girl or member of mathematics? Okay, now student is a girl. The probability of student is a girl equal to 20 out of 30. Okay, and then members of mathematics society, 5 plus 7. Probability of mathematics society, 5 plus 7 equal to 12 divided by 30. Okay, so then, okay, because this is the probability of a girl, this is the probability of the mathematics members of mathematics society, which include the girls and the boys. So, if you like to answer this question, you like to solve this question, the probability that the society is a girl or a member of the mathematics society, we count the girls twice. Okay, for the girls, 5 plus 50, 5 plus 50. Out of 20, 5 is a member of mathematics society, and the rest, 15, are not. So we count this twice. So we need to come up with probability of G intersect with the N, okay, which is equal to 5 over 30. Again, the probability of girls is 20, which is 5 plus 15. 5 out of 20, so 5 is a members of mathematics society, and 15 are not. And the second is probability of members of mathematics society, which include 5 girls, the same person here, and the boys, 7, which 5 plus 7 equal to 12. So to find this, the probability of G union M, what is the probability of the student is a girl or a member of mathematics society? So it is probability of girl plus probability of members of mathematics society minus probability of members of mathematics society intersect with a girl. Okay, so probability of the girls, 20 over 30. The probability of members of mathematics society, 12 divided by 30 minus intersect between the mathematics society members of the intersect with the girls, which is 5 over 30. Then this gives you 20 plus 12, 32, minus 5, 27 over 30, or simplify this, it gives you 9 over 30. An integer is selected randomly from a set of integers 1, 2, 3, 4 until 12, find the probability that integer is an even number or is divisible by 3, even number is not divisible by 3, and okay. So please be careful with the term of or and because or represented by the symbol of union and represented by the symbol of here intersection. Okay, not an even number and not divisible by 3. Okay, so then from the numbers of a set of numbers from 1 until 12, so let A is an even number is chosen, okay, which is equal to 2, 4, 6, 8, 10, 12. And let B equal to even that the chosen number is divisible by 3, which is 3, 6, 9, and 12. Okay, so then the first question then, find the probability that integer is an even number, okay, or is divisible by 3. So the probability of A union B equal to the probability of A plus probability of even B minus probability of A intersect B. Okay, so probability of A is an even number. The total numbers that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability of set numbers here is 12. So then this one will give you 2, 4, 6. So 6 over 12. Probability of B 3, 6, 9, 12. 4 over 12. And then the intercept we call the similar we call redundant between A and B here. Look at this one, 6, 6, 12, and 12. So the probability of even A intersect B equal to 2 over 12. So right down here is 2 over 12. Then 6 plus 4 equal to 10 minus 2 equal to 8, 8 over 12. Okay, 8 over 12, which is equal to 2 over 3. Then next, probability of A intersect with B complement. Okay, so let B even that numbers chosen is divisible by 3. So B complement, the rest of it, okay, when numbers or the total numbers here is 12 minus 4, then it is equal to 6. So PB equal to 1, 2, 3, 4, 4 out of 12 over 12. So the complement of B, okay, complement of B equal to 8 over 12. Okay, class. If I try to elaborate this using, let's say, this Venn diagram. Okay, this is an event of A, and this is an event of B. So probability of A, okay, the probability of A, okay, intersect with probability of B complement. B complement means that any we call numbers that outside of the ring of the circle of B, which is not B. Okay, B complement is everything that which is not B. Not B meaning including outside here, then including part of the A. So intersection between A, the whole circle of A, intersect with complement of B, which is not B. So where the intersection then? Here. Okay. So we can define this as a probability of A minus probability of A union B. Okay, the whole A minus intersection between A and B, then you get A here. Okay, then now it is equal to 6/12 minus 2/12, which is equal to 1/3. And then the next question, the probability of A is getting even number union B complement. Okay, what's the question then just now? Not even number and not divisible by 3. Okay, we call the probability of not even number and not probability of we call not even, then we call the numbers that divisible by 3. Then it is 1 minus probability of A union B equal to 1 minus 2/3 equal to 1/3. Okay, next. Sometimes information is also given in the table form. Value of probability is defined based on that information. Then, so let A, B, C, and D are 4 events that can be written on the table here. Okay. So a survey is conducted on a group of workers comprising of production operators, admins, officers, and security guards. The survey is determined by the total working hours in a week. Okay. So, from all the information in this statement, then we present it, okay, clearly in this table. Okay. So 3 different sections: production operators, admins, officers, and security guards. And from the surveys, they found that the numbers of the workers in every sectors, which is working less than 40 hours a week, 50 to 70, and greater than more than 70 hours a week. So we define it in this table so we can see clearly. So one of the workers survey is randomly selected based on information. Calculate the probability of. Okay, so these are all the questions for A, B, C, and D for the previous we call from the previous table. Okay, so now let P equal to workers of production operator. A equal to workers is an admin, officer, and S, the workers is a security guard. Okay. So then, the first question then, workers being a production officer. Okay. From the table, workers of production officers, production operators, 63, 46, and wait a minute. Okay, guys, girls, before we continue with the questions then, I think that I need to declare what is the total of workers here. Okay, so it's 196 plus 43 plus 31 equal to 270. Okay, so then let's solve the first question then. The first one, okay, let me refer to this. Workers being a production office we call office operator. So the property of production officer, P, workers are production officer, here production operator. The total is 196 divided by, okay, the total of production operator 196 divided by the total of all the workers in the factories, which is 270. Okay, divide by 196 plus 43 plus 31 equal to 196 divided by 270. Okay, you may leave it with answers like this, or we may simplify. Okay, so 98 divided by 135. Then the next question, workers who work between 50 to 70 hours. Okay, so the property of workers work between 50 to 70 hours. Okay, it means that we need to refer to the table again. Working 50 to 70 hours, which is equal to 46 plus 14 plus 10. Okay, 46 plus 14 plus 10 equal to 70. Okay. Oh, yeah, there's total here, 70, sorry. So then, equal to 70 divided by, okay, 88 plus 70 plus 112. 88 plus 70 divided by 112 is still 270. Okay, 270, which is equal to 7/27. Then C, the property of A, workers is an admin officer, intersect with working more than 70 hours, which is equal to, okay, is an workers is an admin officer and working more than 70 hours. Let's see. Okay, so this is an admin officer, 21, 14, and 8. But then the numbers of admin officer working more than 70 hours, 8. Okay, so then straightly it is from the table 8 divided by 270. Simplify this, equal to 4 divided by 135. And then D, the probability of security which working less than 40 hours. Okay, security less than 14 hours, 4 of them, out total of 270. 4 divided by 270 equal to 2 divided by 135. Okay, probability involves combination and permutation. So then the probability, this topic, involved with the topic 7 that we discussed before, combination and permutation. A letter are chosen randomly from the word of computer. Find the probability of 4 letters chosen are consonant. Letter C must be chosen and letters M and P must be chosen simultaneously. Okay, so then the first one then, let A is an event. A is an event of 4 letters chosen are consonant. So class, letters of A, B, C, D until Z is divided into 2 parts, which is consonant and vowel. So consonant, okay, which is B, C, D, and so on. And vowel, only A, E, I, O, and U, full stop. So the rest of A, E, I, O, U is all consonant. Okay, now, and S equal to, okay, event of 4 letters chosen are consonant from the word of computer. So 1, 2, 3, 4, 5, 6, 7, 8. From the total of 8 letters from the word of computer, we choose 4 equal to 70 ways of choosing the 4 letters from the word of computer. Now, the number of 8 here, 5, consonant, 1, 2, 3, 4, and 5. So 5C4 equal to 5. Then the probability of getting all consonant, okay, equal to 5 divided by 70, which is 1/40. All 4 letters chosen are consonant. Okay. So then, question B, letter C must be chosen. Well, letter C must be chosen is a must from the word of computer 1, 2, 3, 4, 5, 6, 7, 8, and then from the numbers of letters here is 8, E1, and we like to choose 4 letters, 1, 2, 3, 4. But then the letter C must be chosen. C is a must. So there's only one C, so 1C1. Okay, so how many places left here now? 3. So the rest of it is, okay, so C has been taken here, so what's left now? 1, 2, 3, 4, 5, 6, 7. So that's 7C3 equal to 35. So then the probability of event B here, probability of event C is chosen equal to 35 divided by 70 equal to 1/2. C, let's see, is an event of choosing M and P simultaneously. Okay, then the event of C, M, and P simultaneously, okay, means that M and P it's a must. So there are only one M and one P. 1 plus 1 equal to 2. So out of these two, we choose or we take both of them, M and P. Then multiplied with, so M and P have been taken here. So what's left now? COUTER. 1, 2, 3, 4, 5, 6. So 6 letters left here now. Then we choose another 2. So use the calculator. The get answer here is 15. So then the probability of getting as event C, M, and choosing M and P simultaneously equal to 15 divided by 70 equal to 3/40. Red marbles. Okay, 3 red marbles, 4 yellow marbles, and 2 green marbles are arranged in one row on the table. Find the probability that all 4 yellow marbles must be arranged together. Okay, so means that, just imagine that on this table, okay, on this table, we need to arrange them with 3 red marbles, 1, 2, 3, 4 yellow, 1, 2, 3, 4, and 2 green, 1 and 2. So all these numbers, 7, okay, 3 red marbles, 4 yellow marbles, and 2 green. So the total 3 plus 4 equal to 7 plus 2 equal to 9. 9 marbles. So we can arrange them in a different ways of these colors then here. Okay, now, okay, so the first one then, semester set here, which is the total of all the marbles are 9. Again, 3 red marbles plus 4 yellow marbles plus 2 green marbles. So 3 plus 4 equal to 7 plus 2 equal to 9. So then it is 9 factorial of arranging we call the marbles. And don't forget they're identical. There will be 3 marbles. So divide by 3 factorial, 4 factorial, and 2 factorial equal to 1260. So let A is an event that 4 yellow marbles, 4 yellow marbles are arranged next to each other. Okay, let's give a picture of this. 3 red, 4 yellow, and 2 green. So among these colors, we can arrange in many ways. Okay, red, yellow, green, red, yellow, green, yellow, yellow. For example, on 3, red, yellow, yellow, red, yellow, green, green, yellow, and red. Okay, you just arrange it as many ways as you can. But then the event A here, 4 yellow marbles are arranged next to each other. So just imagine that if these 4 will never separate. So we imagine that these 4 as one unit. So if we arrange it 4 here, or might be in between this 5, okay? So we consider this as 5 is as a 1 unit. So 1, 2, 3, 4, 5, and 6. Okay, so then NA equal to 6 factorial divided by, okay, 4 yellow marbles divide by 3 red marbles, 3 factorials, and 2 green, 2 factorial, which is equal to 60. So the probability of getting event A, where event A is 4 yellow marbles next to each other, equal to 60 divided by 1,260, which is 1 over 21. Okay. It might be, for some of you have no idea, why do we say this as a 1 unit? This is yellow, 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 and yellow. If I give you another picture of this, 1, 2, 3, 4, 5, 6, 7, 8, 9. Just imagine that it's a yellow here. So they are next to each other then, they never separate. So we consider it as another 1 unit. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Okay. And then question B, 4 yellow marbles are not arranged. 4 yellow marbles are not arranged next to each other. Okay, so that means that the complement of event of A, this is event of A where the arrangement, 4 yellow marbles next to each other. So oppositely or complement equal to 1 minus probability of A. So then it is 1 minus 1 over 21, that is equal to 20 over 21. Okay, next, question C. The green marbles must be in the first and the last position of the rows. Okay, because there are two green marbles only. So there's a 1 places 1, 2, 3, 4, 5, 6, 7, 8, 9. So green marbles, the first and the last here. Okay. So out of 9 marbles, we only need to, out of 9 marbles, 2 of green for the end on left and right. So how many places left in here? 7. 1, 2, 3, 4, 5, 6, 7. And how many marbles left? Also 7. So then the arrangement will be green marbles be first and the last position. Here it is 7 factorial divided by 3 red, 4 yellow, and 2 green, where 2 green is already here and here. So 3 plus 4 equal to 7. So the 7 factorial divided by 3 of the red, identical 3 factorial and 4 factorial, equal to 35. So probability of B is the green marbles must be in the first and last position of the row. It is equal to 35 divided by 1,260, which is equal to 1 over 26. So the next is mutually exclusive event if they cannot occur at the same time. Okay, they cannot. Event A, neither A or B can occur simultaneously. So probability of A and B occurring at the same time is 0. Okay, it's here. Means that there is no intersection, there is no what we call then element in A that also shared by element in B. So they are separated here. So then next one, example 6, C and D are two events when probability of C equal to 0.1, probability of D equal to 0.2, and probability of C union D equal to 0.3. Determine whether C and D are two mutually exclusive events. Okay, so we're going to find that all these property of C complement and C complement intersect with the D complement. Okay, so then for question A, given that probability of C union D equal to 0.3, and then probability of C plus probability of D equal to 0.1 plus 0.2, which is equal to 0.3. Okay, so probability of C union D equal to probability of C plus probability of D, which is 0.3. Okay, probability of C union D equal to probability of C plus probability of D. Since that there is no intersection between C and D, so then C and D are mutually exclusive events. And next, for B, probability of C complement equal to 1 minus probability of C. So then 1 minus 0.1, so please refer to the question then, probability of C equal to 0.1, so then give you 0.9. And then probability of C complement intersect with D complement. Okay, so it is 1 minus probability of C union D, it is 1 minus 0.3. We found it because we have proved this in the question of A, so then it is now 0.7. Okay. Okay, so we have reached what we call the exercise for this question. For exercise, for you to try. Okay, the final answer is provide that. So try yourself. Okay, for question number 2, for question A here, it is 11/75, and B is 39 divided by 75. Okay, so that's all for today, and I do hope that this video helps you, and please don't forget to continue your tutorial and concept questions. That's all. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.